My name is Hamid Ekhtiyari. I'm really delighted to be here, and I should thank our chairs here because Colin and Tony, they had a really good role in terms of bringing people together and make friendship. And just before the session, we have been discussing about what we are doing and how we might be able to help each other. And I realized that the level of friendship that we develop over these years and how we can just basically share the resources that we have, the ideas, and that is a great thing to see in the field of addiction neuromodulation. And that makes me really hopeful that we can make something together. So that is the excitement that I have in the field. But before getting started, I do not have any conflict of interest. I should thank my colleagues and collaborators in the University of Minnesota. Right now, we have Kelvin Lim here from our team there, and also my kind of supervisors and collaborators at Laureate Institute for Brain Research. And all the things I'm presenting would not be possible without their support. So when we discuss about addiction neuromodulation, how many trials do we have that they try to use TES or TMS for addiction, trying to kind of find a treatment? Any estimate? How many published trials do we have right now? Okay, so we have around over 200 publications so far that people tried in a kind of randomized clinical trials. They tried to see how we might be able to find a treatment with neuromodulation for addiction. And people try, as you can imagine, different modalities and different kind of substances for target. And if you look into the kind of meta-analysis point of view in terms of whether they have been able to find some effects, you can see that, yes, there is a kind of a moderate, sometimes to small kind of overall effect with TMS on drug craving and also drug consumption. And it is true for transcranial electrical stimulation as well, while the effect size is smaller in transcranial electrical stimulation compared to TMS. But people are doing lots of different things. So when you look into the areas that people targeted in addiction, you can see people tried many different targets around the brain. And it's really hard. I mean, you can put them together in a meta-analysis and report, okay, there is an effect for neuromodulation addiction. But in reality, people have done many different things. And that is interesting to see how people try different targets. And even when you go into specific targets, for example, as you can see here, when we talk about DLPFC, if you go to just only DLPFC, you see that people tried different ways of targeting DLPFC. And there are different methods that people tried, and all of them are based on different structural measures that they try to kind of find the best target and right target in DLPFC. But the question is, are they the best way to target for addiction neuromodulation? As you know, in the field of depression, now people are moving forward beyond just the anatomical targeting, and people are trying to see how we might be able to target based on some neurochemical measures like PET, group-based connectivity measures, or what we call individualized, functional connectivity-based, personalized interventions. But the question is, when we discuss about depression, people are concluding, most of the teams, that probably the connection between DLPFC, subgenual cingulate cortex, would be the best target to modulate. And this is something that people are building up for individualized targeting. But the question is, what is the right target for addiction? And that is something that people are still discussing in terms of what is the kind of the right biomarker, targeting biomarker that we can have for addiction, and there are definitely different models. Elliot Eshton is not here, but he was kind of discussing about the idea of interaction between default mode network and executive control network. And when we get to craving, we have more engagement of default mode network. And this is what Heather was presenting today in terms of the importance of default mode network in drug craving. And then when we go out of that craving, then we have more engagement of executive control network. And this is how we can basically expand the model in something that is basically interaction between default mode network and executive control network, and how we might be able to target different areas on that sort of framework. So that could be one of the frameworks. But even in that framework, you can see we can have multiple targets. So the idea of, for example, engaging executive control network and how we might be able to optimize target engagement in executive control network One of the technologies that we use is what we call frontoparietal synchronization, trying to target frontoparietal network with multiple electrodes. But when you go and you try to find the right targets, when we start with something like a F3 and F4, and P3 and P4, that is a work that is being done by one of my postdocs, Ghazal Soleimani, we try to see if we go and try to modulate between F3 and P3 or F4 and P4, what we will have. But the interesting thing is when you want to see the connections between these two sites, F4 and P4 and F3 and P3, in the context of drug-Q reactivity, those sites are not actually connected to each other. And that was pretty frustrating for us because we have been interested to see engagement or interactions between these executive control nodes when people are seeing drug-related cues. So we did an analysis, we basically put the seed over DLPFC, and we realized, yes, there is a kind of activation, a significant connection in the parietal part. But that site is not actually under P3 or P4. And we realized if we want to target that, we need to go for CP5, CP6. So we need to optimize the executive control network based on what we need to have. And if you put those kind of seeds on those kind of CP5, CP6, you can see now we have the right connectivity, and these kind of sites are actually engaged to each other. Then we started to think about those. When we put the electrodes over F3 and P3, that is and we deliver 2 milliamp of electrical current. As you can see here, that is a distribution of electricity in those nodes among 60 individuals. So there is a sort of wide range of distribution in terms of how much electricity people would receive. But the challenging part is, as you can see here, there is an inter-individual variation, but both sides on average would receive the same amount of current. But when you change the montage to the new montage, the distribution is different. So even in the group level, if you want to optimize the stimulation, you need to deliver different amount of current in different sites. So we need to do optimization in both in the group level and also in an individual level. So that is kind of a message that we have when you consider the dose and what we have in that site. So we published that specific kind of pipeline. If you want to optimize the stimulation and engage the frontoparietal network, you need to find the right frontoparietal network for the target engagement and the right dosing for that. Now what we are doing, we are running what we call a concurrent TES fMRI inside the scanner while we expose people to drug-related cues, and we engage those networks at the individual level. So that is kind of a new trial that we are running based on that specific pipeline. But going back to the model that we have been discussing and how we might be able to target other areas. One of the areas that people tried very frequently is what we call kind of DLPFC, mainly on F3, F4 areas. And this is what we did before, something like 10 years ago, try to engage basically DLPFC network when we expose people to drug-related cues with putting the electrodes on the right DLPFC and cathodal on the left DLPFC. And we showed that we can basically reduce the level of craving when we put the electrodes on these two sides. And we have been thinking, okay, we are engaging DLPFC, that is the reason that we have that level of craving reduction. But in reality, when you do modeling of when you put the electrodes on these two sides, what would be the area that actually receives the electricity inside the brain? And this is what you will see. When you put the electrodes on these two sides over the brain, the area that will receive the highest level of electricity is actually frontopolar area. And this is something that we recently published in Human Brain Mapping, that all those studies that they report that when we kind of basically stimulate DLPFC with electrical stimulation, they are actually stimulating the highest level of electricity would be in the frontopolar cortex. And it is in line with the new study that Michael Fox published in terms of frontopolar area would be probably the best area or one of the best targets for neuromodulation in addiction. And it seems that those things are in line with each other. But as you can see, this is kind of a distribution of electrical current in 60 individuals. And you can see how, these are 60 methamphetamine users, how the distribution is different across different people in the population. And we did an analysis in terms of dose-response relationship, and we showed that the changes basically in the level of electricity in the frontopolar cortex could be one of the predictors of response to TES. So that is the kind of the idea that we had in terms of, okay, it seems that they match to each other really well. So, and it's interesting that in the fMRI drug Q-reactivity, we also have a good engagement of that frontopolar side. So we have been thinking, that is interesting. I mean, that lesion study from Michael Fox's team, the Q-reactivity data that we have, the modeling data that we have, it seems that they are converging to each other. They contacted Colin, and Colin has kind of lots of data with nicotine and alcohol. So I was asking Colin, could you share your data with fMRI drug Q-reactive to see if you have the same sort of site in your data? And we realized that, yes, I mean, it seems that the same site has engagement when we have fMRI drug Q-reactivity in smoking and alcohol as well, which was kind of convincing that it seems that that area across different substances has a significant engagement, and we might be able to target that area. And also there is a kind of a new line of research that they showed that the coils that has been the deep coils that people have used for smoking, they target the same sort of frontopolar area, and they showed kind of being effective to modulate craving in smoking and also in alcohol use disorder, and they are basically targeting the same area. So it seems that there is a converging evidence that that area could be a potential target for drug Q-reactivity. And Colin Hanlon is one of the, kind of, I should say, the first person or one of the key people that basically introduced that area. And I was thinking, I mean, we probably can kind of name that area after Colin's name. Colin Hanlon's kind of medial prefrontal cortical area. That is the area that she showed in the kind of the first very initial studies in the field. That is the target for neuromodulation in addiction. And that area also targets the frontopolar cortex at the end of the day, which is really convincing. So we put all those pieces of evidence from modeling studies, from previous trials, from dose response kind of relationship, and this has just been published in American Journal of Psychiatry as some like converging piece of evidence that show frontopolar cortex could be one of the targets for addiction neuromodulation. But to target that specific area, kind of ventromedial prefrontal cortex or frontopolar cortex, what are the things that could be important? There is a study by Elliot Stein team and Brian Adinoff that they showed that in their studies, the connection between frontopolar cortex and amygdala was the main driver or predictor of relapse in cocaine users. And interestingly, in our fMRI drug Q-reactivity data, whenever we have activation in the frontopolar cortex, that area is connected to left centromedial amygdala and also negatively connected to right DLPFC. So these are the areas that we consistently have in our fMRI results. And that is something that we started to think about, okay, how that could be a target for neuromodulation. So that is what we see in terms of the activations in different parts of the brain, but basically left centromedial amygdala has the highest level of activation when we have fMRI drug Q-reactivity. So we started with that seed, and we tried to see, in the group level, we have significant frontopolar engagement with left centromedial amygdala, okay? But the question was, if we go in the frontopolar side and try to see if we find individual connections from left centromedial amygdala to that space and find the highest level of connectivity, how much those seeds of connections or how much those sites of connections would vary across frontopolar cortex, okay? And this is what you see. I mean, there is a wide range of variation. When you go in the individual level, people have different connections to different parts of frontopolar cortex. And that is the way that we try to see how those connections could be important. And we showed that basically the connection to those areas in the frontopolar cortex in an individual level would be related to the level of craving that people would experience. But to be able to target that and define personalized targeting, as you can see here, that is the kind of space that we have for individualized frontopolar targeting based on the connections to amygdala. And we showed that even the orientation of TMS coil would be important in terms of the level of kind of electricity that you deliver to those areas. So we basically need to optimize even the direction of the coil. And to be able to do that, we are currently using basically robotic arms to be able to optimize even the direction of the coil. And also, we realized that there would be significant inter-individual variations in terms of the dose of electricity that people would receive on that area. And that factor should be also optimized if we want to have the highest level of electrical current that is going to be delivered on that specific individualized site. And that is another level of optimization that we need. That is something that we put together as something like a pipeline for individualization, and that is the data, and the pipeline is already available if somebody is interested to use that specific pipeline. But going back to what we had in terms of the frontopolar DLPFC engagement, we realized that kind of network of connection between frontopolar, amygdala, nucleus accumbens, that is the connections that we have on that side. And then we have a network of connections with DLPFC, and these are all PPI connectivity. So these are task-based connectivity in the context of Q exposure when we put people inside the scanner. So it seems that there is something like a network that we might be able to target, not only from VMPFC, but also from the DLPFC side with different modes of stimulation. And this is basically the network that we have. And now we are working in terms of how to find individualized targeting in that network level, engaging both ventromedial prefrontal cortex and also DLPFC. Now we are looking into individualized targets in the frontopolar cortex and also individualized targets in the DLPFC area. And now we can show something like a triangle in each individual participant that we have that has one side in the frontopolar cortex, the other side on DLPFC. And this is what you see in terms of distribution of individualized connections between amygdala and frontopolar. As you see that there is kind of a positive distribution of connections and also a negative distribution of connection. And I think it is critically important for us to show individual level data in terms of what is the distribution of individual level data, because there is a huge variation when we do neuromodulation. It's important to basically show what we have in an individual level kind of data that we have. And this is what we have in terms of the optimization that we can do in individual level. And this is basically a poster that we are going to present tomorrow discussing about technical details, how that could be possible. But the idea of a dual neuromodulation or multiple neuromodulation target in the field of addiction and how that those different neuromodulatory targets could be individually optimized. And now we are moving and we try to do what we call closing the loop between brain state and brain stimulation. And this is a new sort of pipeline that we put together for closed loop electrical stimulation inside the scanner. And this is a new publication, Translational Psychiatry, discussing about the optimization and how that could be happening. And this is a kind of a new protocol paper that we discuss how that is technically feasible. And now we are doing that with basically drug-Q reactivity inside the scanner, closing the loop to be able to optimize stimulation parameters while we expose people to drug-related cues to engage the state and also optimize the stimulation based on the state in an individual level. Some take-home notes. We discussed about addiction targeting biomarker model and different models that we have and different targets that we can have at that model. We have probably multiple biomarker targets for addiction, large inter-individual variability, targets that should be spatially optimized, and also we can have both group level optimization and also individual level optimization, and also dose optimization. Dose optimization is something that in many studies have been sort of not paid enough attention to, but that is something that we can consider in the future in terms of how to optimize those in an individual level. And also discussing about predictive biomarkers. Can we find and define, okay, for this specific individual, that target is going to be the optimized target, or for those who are non-responding to that protocol, then we can move to the other targets and try the other targets that we have for stimulation. And also, there are definitely challenges for personalized trials in the field of addiction neuromodulation, also in other areas, because you always have the challenge in terms of when I have a personalized neuromodulatory trial, what would be the best control intervention? And all the studies that are published so far, and they have positive findings with individualized neuromodulation, their control condition is a sort of sham condition. So it's really hard right now to say whether individualization is actually going to make a difference when you compare individualization compared to some like a group average targeting or a scope-based targeting. And that is something that we need to pay attention. And that is another level of discussion in terms of how to push the field forward if we have those challenges. Last slides. It is not only us in the US that we are doing the addiction neuromodulation. So people around the world, there are different networks which are pretty active in the field, and we need to learn from each other. So we realized that we need to have a network of labs that are doing addiction neuromodulation. So we made a network of people who are working in the field of addiction neuromodulation, and we try to bring them together to collaborate to see how we can basically learn from each other and learn from the experience that people are doing around the world. And I mean, if you are interested to be a part of that network, we definitely would be happy to have you as a part of that network. And also we have group of people who are interested to use drug cue reactivity and fMRI drug cue reactivity as a biomarker. And that is another network that many of colleagues here are a part of that network. I can see Rita here right now, many others, Kathleen is here, many other people who are involved in that process in terms of collaborating to each other to see fMRI drug cue reactivity as a biomarker for target engagement. So we try to see how we might be able to collaborate on that side as well. So we'll have a specific meeting on neuromodulation meeting in New York City by the end of July. We are going to have further discussions about how to bring people together and extend the collaboration. I should thank my colleagues and collaborators, especially Ghazaleh Soleimani, who did some of the analysis that we presented today, and many others who made it possible for us to present these things today here. Thank you very much for your attention.